What's going on, guys? Keen here. I hope you're doing well. And in today's video, we're taking a deep dive into DeepSeek, specifically DeepSeek-R1, incentivizing reasoning capability in LLMs with RL. So this paper dropped yesterday, and it was a real treat to read. So I hope I can convey the knowledge I learned to you today. And we're going to skip the abstract because we want to get the deep understanding, nothing surface level. And let's read the introduction here. So the first thing they start off with is mentioning OpenAI's O1 model because it was the first model to introduce inference time scaling via chain of thought reasoning processes and specifically increasing that length. And the goal of this paper, of course, is exploring if we can completely remove supervised fine-tuning and replace it with reinforcement learning to develop those same reasoning capabilities. And we'll see that this is partially successful. So they have one model which is purely RL that has some issues, and those issues are in fact poor readability and language mixing. So we'll discuss this more in detail, but language mixing, for example, can be English or French or different types of languages being mixed up. But to address these issues, they of course introduce DeepSeek-R1. So these are the challenges here once again. And how DeepSeek-R1 is different from R1.0 is that it has the cold start data. And this is a very key aspect which we will talk about in further detail. And not only does it have cold start data, but they also introduce a multi-stage training pipeline. So it's split up into 4 stages, which we'll break down one by one. But I just want to start this video by mirroring this to DeepMind and AlphaGo 0. So all of the variants of Alpha 0 that played Go and revolutionized deep learning, essentially. Of course, there was AlexNet, but this was a more mainstream task. And if you compare R1.0 to R1, it's similar to how over time the AlphaGo models became less and less domain dependent. So AlphaGo Fan, for example, which was made in 2015, had a very dense feature and depended on all of the rules of Go, whereas if you fast forward all the way to Mu0, it learned the rules and learned a game representation simply by watching games and using RL. And we can see here that R1 is completely RL dependent, whereas R1.0 does use some cold start data. So we can compare R1.0 to the early stages of AlphaGo, where they were more dependent on data, and R1 as choosing a pure RL path. And my hypothesis is that over time, just as was the case with AlphaGo, models like R1.0, which have a 100% dependence on RL, will become better and better and will scale better than models such as R1, which use cold start data. So that's our introduction here. And let's now go to the contributions, which are split into 2 categories. So there's post-training contributions. Once again, they directly apply RL to the base model without any supervised fine-tuning. And this is really revolutionary because ever since generative pre-trained transformers have become the paradigm, fine-tuning has been essentially one of the most essential aspects of training those models. So we're completely replacing with reinforcement learning. This is the first contribution. And they're also, once again, the first open research initiative to validate whether we can completely replace supervised fine-tuning with RL and still achieve reasoning capabilities. And in the words of the author, this breakthrough paves the way for future advancements in this area, and I do not doubt it whatsoever. This is extremely significant work. And secondly, they introduced the pipeline used to develop DeepSeek-R1, which has 4 stages split up into 2 parts. So we have 2 RL stages as well as 2 supervised fine-tuning stages. But don't let this make you believe that they're consecutive. In fact, in the R1 process, we have 1 supervised fine-tuning followed by RL, another supervised fine-tuning, and a second RL to iteratively fine-tune the model. So I'll explain why it's in the specific order. And this will be the second topic, the second subject of the video. First, we're going to talk about R1.0. And lastly, they also have the distillation contribution. So they distill R1, which is the cold start model, into smaller models such as DeepSeek with 32 billion on Quen, and they also use Llama. And this is quite interesting because it only uses supervised fine-tuning. So we get the RL model, and then we distill it in a sort of teacher-student setting with purely supervised fine-tuning. So you can see here, we fine-tuned several dense models, and the results are quite exceptional. So we'll discuss this. It in fact beats GPT-4o and 3.5 Sonnet in math task. So this is also interesting, and it slightly mirrors something from 2021, which was the decision transformer. So decision transformer essentially reformulated the task of reinforcement learning in the context of large language models. And if you'd like, I'll link the video. I'll link the paper. You can read more. But in this instance as well, we're mimicking reinforcement learning purely through supervised fine-tuning. So I thought that was an interesting parallel between the decision transformer released by Peter Abiel's lab, as well as the supervised fine-tuning on distilled models. So in the approach, we're gonna give a quick overview. So as authors state, current LLMs rely heavily on large amounts of supervised fine-tuning data, but in this study, we're going to see with our own eyes that large-scale RL, even without supervised fine-tuning, can achieve non-trivial performance, in particular with reasoning tasks. However, they do state that performance can be enhanced with the inclusion of a small amount of cold start data. Okay, so we're going to jump right in to DeepSeek-R1 the first of 3 models. And in this task, we will look first at GRPO. So this is Group Relative Policy Optimization, and it's a variant of Proximal Policy Optimization, PPO, which is perhaps the most well-known reinforcement learning algorithm. And that was released by OpenAI in 2017, in particular by John Schulman and his collaborators. So you might have heard of that name before. So it's coming full circle. And GRPO, you can think of it as a memory efficient method of PPO. I won't jump into the formulas of the policy and that information because that would take an entire video, but I will discuss the main principle behind it. So in GRPO, we are using an actor-critic reinforcement learning model. However, the critic, which you can think of as the value function, is replaced by the group average output. And the group average output is this line right here. And what you call this here is advantage. So advantage is calculated for every output within the policy. And I'll give you a concrete example. So let's say we're performing a reasoning task, and it's a math problem to find the solutions of y equals x squared minus 1. So a few possible ways to solve this problem would be taking the derivative. We can also use the quadratic formula, the famous negative b plus or minus square root of b squared minus 4ac, etc. And since the model is training, it can also propose a completely false chain of thought response. So in this case, we would have 3 values from 1 to 3, and we would have 3 advantage calculations. So you can posit that the derivative approach and the quadratic formula approach should both have approximately the same reward from the model because they both are valid chains of thoughts. However, R3, which would give us incorrect answer, should have a bad performance. So you can already see that if we compare R3 to the mean, it will be negative, whereas the other 2 will be positive. And we also scale it by the group standard deviation. This is all to say that anything which is valid and is properly produced by the policy will have a positive advantage. And then we use this advantage in our policy update to ensure that the network moves towards better performing outputs over time. So this is how we can start off with poor reasoning skills and iteratively improve it over time. And if you'd like to have a deeper understanding of GRPO, I'll link the paper. This is, in fact, this was produced by DeepSeek last year, as you can see, 2024. So it is a very new algorithm, and I think it's quite impressive how they modified the algorithm for memory efficiency, because this policy is used extensively in the training process in order to essentially make the critic this simple calculation and only have the actor network instead as our main model. So that was GRPO. Now let's move on to this training template. So as you can see, there are 2 types of HTML tags here. We have the answer tags as well as the think tags. And this is to prompt the model to put its chain of thought reasoning within the think tags, and then the answer, as you can see between the answer tags. So it's as simple as that. This is how the model is trained. And if we skip down here, we can see that the authors state that they limited the output format. So they didn't have a extremely structured or overbearing output in order to avoid any biases, such as mandating a specific reflective reasoning. So perhaps they could have had a template where it says, okay, you're going to think this way, etc., or promoting a particular problem-solving strategy. So once again, the simple template is to debias the model and ensure that it has a natural progression. Okay, now if we skip back up here, we have the reward model setting. So when we train the policy, we have to give it a reward signal so that it improves. And there's two rewards, which are combined via addition. It doesn't say it specifically in the paper, but that's my best guess. And it has an accuracy reward as well as a format reward. So the format reward is the simplest. It simply gives the model a score on whether or not it followed the template. And an accuracy reward is best illustrated through the two examples here. So if it's a math problem, then the reward is based on whether it has the correct answer in a specific box. And if it's a LeetCode problem, then it will simply compile the code that was outputted and check if it's true or false. So these two rewards, accuracy and format, are used to train DeepSeek-R1 0. However, when it comes to DeepSeek-R1, you'll see that there's a third parameter added in order to ensure that the model is aligned with human desires. So you'll see what I mean by that later. And if we scroll down here, we get to my favorite part of the paper. So we can see it's titled Performance, Self-Evolution, and Aha Moment of DeepSeek-R1 0. So what is intimated by this? First of all, there's a diagram here. It's somewhat interesting. It shows the training performance over time and compares that to some O1 benchmarks. And what you can see here is that there are certain spikes in training. And what's hypothesized is that these certain spikes are a result of aha moments. So one aha moment you can think of, and we'll see it in the example right here, so just stay tuned, is the model learns to reevaluate if it's on the incorrect path. So if it's going the wrong way in a reasoning process, it will go back. And some of these peaks are certainly because of that, or some emergent behavior which allows it to solve problems better. But that's only in the realm of hypothesis, so we don't know exactly what's happening there. But to get back to self-evolution, there's specific spikes in model performance that might be correlated with these aha moments. And as you can see in this graph, DeepSeek-R1 0 learns to solve reasoning tasks with more thinking time, that is to say, more response length, so more time dedicated to chain of thought as the training progresses. So behaviors such as reflection here, where the model revisits and reevaluates its previous steps, and exploration of alternative approaches to problem solving arises spontaneously, and they're not explicitly programmed, but instead simply result as the model's interaction with the RL environment. This spontaneous development obviously enhances its ability to perform reasoning tasks with more accuracy and efficiency. So the specific aha moment here is regarding the following equation. So when it first prompts itself, it is, of course, in the think bracket. So we're talking about formatting here. So it wants to be in the right format. And it's on an incorrect path. I tried to parse this, but I don't really understand what's happening here. And then this is the annotator. So this red line wasn't from DeepSeek-R1 itself, but rather an annotator. So at some point, the model said, let's reevaluate, and then went on the correct path. So this clearly shows the improvement of reasoning of DeepSeek-R1 over time. And one of my favorite paragraphs in the paper is this aha moment is not only an aha moment for the model, but also for researchers, because it underscores the beauty of RL. Rather than explicitly teaching the model how to solve a problem, we simply give it the right incentives through the reward, and it independently develops those advanced problem-solving skills that are synonymous with reasoning models such as O1. And it's a powerful reminder of the potential to RL and is likely only going to be compounded in the future. So although we talked about all of these great benefits, there are the challenges I mentioned. So it's mainly poor readability and the language mixing. So the example they give is markdown. So when there's markdown formatting, sometimes it messes it up completely. And this is solved with DeepSeek-R1. So now we're in the second part of the video where we will discuss the model which has cold start data and is split up into 4 stages of training. So to give you a quick rundown before we get into each one, the first stage is supervised fine-tuned training on DeepSeek V3 base. So that was the model published in December, and it uses the V3 base as well as cold start data to get a fine-tuned model. Then we perform reasoning-oriented RL on the fine-tuned V3 base, identical to how it's done in R1.0. Once the reinforcement learning converges in our second stage, we create new supervised fine-tuning data through rejection sampling. I'll explain what rejection sampling is on the checkpoint of the second stage. And then we combine this with supervised data from DeepSeek V3 to retrain the base model. So if you are following up to now, we retrain DeepSeek V3 base twice. We train it once, the base model in the first stage, and then a second time at the third step. And at the third step, once we retrain it on the new supervised fine-tuned data, then we run a fourth and final RL stage, and the output of that stage is R1. So that's the final checkpoint. Okay, and let's go into collecting the cold start data. So this is done in many different ways that they propose. So they use few shot prompting with a long chain of thought as an example. There's also directly prompting V3 or other models to generate detailed answers so that the model, when it learns, can essentially copy what chain of thought looks like. And one problem, though, is that gathering the R1.0 outputs in a readable format requires post-processing by human annotators. So using R1.0 to train R1 is possible. However, it needs to be annotated because of the aforementioned readability and mixed language issues. So I mentioned that the cold start data helps. Why exactly? First of all, the readability. I'm not going to stress on that too much more, but it also helps with imbuing human priors. Okay, and like I said, the second stage is the reasoning-oriented RL, and this is done after we perform the fine-tuning. In this instance, we are doing almost the same RL training as was done on R1.0. However, to mitigate the issue of language mixing, they also add a language consistency reward. What does this mean? Simply, in the chain of thought reasoning, in whatever language we're performing that process, we divide the number of terms in that language by the total terms. So if only half of the terms in the chain of thought are in a specific language, then that reward will be half, whereas the maximum reward 1 would be completely in the target language. And they do say that through ablation, this does decrease the model's performance. However, it is for alignment, and therefore that decrease in performance is readily accepted for a better aligned model. So the model has now been trained on an RL process very similar to R1.0, except we add a third component to the reward. So we have the format accuracy, the model accuracy in terms of did it get the question right or wrong, and thirdly, the language alignment score. And now we are going to perform supervised fine-tuning on the base model again, except we're going to collect new data. And whereas the previous data was purely focused on reasoning, this stage also incorporates other domains. So it's 75% reasoning data and 25% non-reasoning. With respect to the reasoning data, they use rejection sampling from the previous checkpoint. And what is rejection sampling? It's a method of generating random samples from a probability distribution. And it works by first sampling from a simpler distribution and then either accepting or rejecting that sample based on the probability ratio between the simpler and the real distribution. The real distribution in this case would be the policy network in the GRPO setting. So this is how we get some reasoning data, but you can also see that they do perform filtering. So they remove any chain of thought with mixed languages, long paragraphs, and code blocks. So this model is not fine-tuned for software engineering, and they'll explain why in the conclusion. And this is giving us 600,000 training samples. And with respect to the non-reasoning tasks, just so that it is capable at having conversations, etc., there's 200,000 training samples, mostly gotten from V3. So these 800,000 data points are the basis for the fourth and final step, which is named reinforcement learning for all scenarios. It's the second reinforcement learning stage aimed at improving the model's helpfulness and harmfulness. It's slightly vague. I'm not sure if they expand in this in later work, but that's all we have in the paper. And they train the model using a combination of reward signals and diverse prompt distributions. So it combines both the RL side as well as diverse prompt distributions, which, if I'm not mistaken, comes from the DeepSeek V3 paper. And it's worth noting that for helpfulness, they only focus on the final summary, which is provided by the model, whereas harmlessness does look at the chain of thought as well as the response. So that's the wrap up of the 4 stages of R1. Now, we do mention distillation here. So we only apply supervised fine-tuning, like I said, and there's no RL stage. And they say here that they leave the exploration to the RL stage for the broader research community. And this is what I'm researching currently to see what we can do with these distilled models using RL. But in this proof of concept, they still managed to produce extremely good performance using supervised fine-tuning on the RL R1 model. So that was all for the distillation. That section is quite simple. They do have some unsuccessful attempts. I'd recommend, if you want to read about MCTS, because that's quite interesting. But since it was unsuccessful, we're not going to waste our time talking about that. And we're going to jump right into the conclusion here. So as they state here, DeepSeek-R1 presents a pure RL approach without relying on cold start data, which is really groundbreaking. I would have never thought that in the first month of 2025 this would be possible. However, DeepSeek-R1 is more powerful by using some cold start data to give the model a push and help it align with human priors as well. One thing I really want to highlight here is that the 1.5 billion parameter distilled model outperforms GPT-4o and Claude 3.5 Sonnet on math benchmarks, which is quite incredible and highlights to what extent this is an efficient model compared to these models, which definitely have more than 1.5 billion parameters. And they do talk about some future goals. The first one is to leverage a general capability and universality, which is similar to V3 in all of these different tasks, since this one is really geared towards reasoning. And this would essentially end the bifurcation, because right now they have V3 and R1. I wouldn't be surprised if in the future they combine these two into one large language model. Furthermore, they do mention the limitations being language mixing. So one thing that is apparently noticed is that even if you prompt the language model in, say, French, it might perform the reasoning in English or Chinese. The intuition for this is that the contextualized token embeddings are semantically similar across all languages, because it's giving you the semantics and not the language. And there's simply more data in English and Chinese. Therefore, the model is more likely to reason in those languages, since it has seen more data in those two languages, since it's the main training is performed on English and Chinese, of course. So this is going to be addressed in the future. There's also the problem of few-shot prompting. So few-shot prompting is used to generate supervised fine-tuning data, but if you want to use few-shot prompting on the final model, then it does degrade performance. So they're going to look into this in the future. But if you are using DeepSeek-R1, then it is recommended to use zero-shot setting for the best results. And lastly, software engineering. So due to the long evaluation times which impact the efficiency of the RL process, large-scale RL has not been applied extensively in the software engineering task. And they do propose 2 ways of implementing this in the future, either through rejection sampling on software engineering data or using asynchronous evaluations during the RL process to improve efficiency. So expect the next generation of DeepSeek-R1 models to be proficient in software engineering as well. And not only that, to be as general as V3, since these are the future goals of the paper. So you can see all of the citations at the bottom if you wish. Otherwise, that's essentially everything I wanted to cover today. I hope you have a better understanding of DeepSeek-R1. And stay tuned for more updates because I'll definitely be making them. And lastly, if you have any feedback, please let me know in the comments.